monotonic functions and the first derivative test. Corollary, suppose that f is continuous on closed interval a comma b and differentiable on open interval a comma b if f prime of x greater than 0 at each point x belongs to open interval a comma b, then f is increasing on closed interval a comma b. If f prime of x less than 0 at each point x belongs to open interval a comma b, then f is decreasing on closed interval a comma b. So after finding derivative of our function f prime was positive, that means our function is increasing on closed interval. But if our f prime was negative, that means our function is decreasing on closed interval. Now what we have here on this part, functions are known as monotonic if they are increasing or decreasing in their entire domain. Now in this part we have first derivative test for local extrema. Suppose that C is critical point of a continuous function f, and that f is differentiable at every point in some interval containing C, except possibly at C itself. Moving across this interval from left to right, if f prime changes from negative to positive at C, then f has a local minimum at C. So what we have here, f prime is less than 0, that means here we have negative, and that changes to what we have here on right side. This f prime is greater than 0, so that is positive. So changing from negative to positive, that means here on this part we have local minimum, and here on this part we have f prime is equal to 0. Now here on this part, if f prime changes from positive to negative at C, then f has a local maximum at C. So based on what we have here on this part, f prime is greater than 0, that means that is positive, and then from left to right that changes to negative. So this means here on this part we have local maximum and f prime is equal to 0. If f prime does not change sign at C, that is f prime is positive on both sides of C or negative on both sides, then f has no local extremum at C. So from left to right, what we have here, f prime is positive, and then here on this part again is positive. That means between these two, here on this part, our function has no local extremum at this point, C1. And that is same for what we have here on this part. So moving from left to right, here f prime is less than 0, and here again is less than 0. So what we have between these two, this point, our function has no local extremum at C5. Examples. Answer the following questions about the function whose derivative is f prime of x equal to x minus 8 times x plus 6 times x minus 10. Part A. What are the critical points of f? Part B. On what open intervals f increasing or decreasing? C. At what points, if any, does f assume local maximum and minimum values? For part A, set f prime of x equal to 0 and solve for x. So here we have x minus 8 equal to 0. X is 8, x plus 6 equal to 0, x is negative 6, and x minus 10 equal to 0, x is 10. Here on this part, derivative, we don't have denominator, so our f prime of x is not undefined. So we don't need to find that part. Now, what we have here, these are critical points of f. So critical points are 8, negative 6, and 10. The three critical points that we have from part A split the domain of the function into 4 non-overlapping open intervals. So what we have here is negative infinite comma negative 6, negative 6 comma positive 8, positive 8, comma, positive 10, and positive 10, comma, positive infinite. Now evaluate f prime. For example, for interval negative infinite, comma, negative 6, evaluate f prime of negative 7. We can use any number that is less than negative 6, and negative 7 is less than negative 6. So here we have x minus 8, so it's negative 7 minus 8 times negative 7 plus 6 times negative 7 minus 10. So I used f prime of x and substitute negative 7, and that is equal to negative 255. So here we have negative number. This means the function is decreasing on the open interval negative infinite, comma, negative 6. Now for interval negative 6, comma, 8, evaluate f prime of 0. 0 is between negative 6 and positive 8. So here we have 0 minus 8 times 0 plus 6 times 0 minus 10. That is equal to 480. Because of having positive number, the function is increasing on the open interval negative 6, comma, 8. For interval 8, comma, 10, evaluate f prime of 9. 9 is between 8 and 10. So f prime of 9 is equal to 9 minus 8 times 9 plus 6 times 9 minus 10, and that is equal to negative 15. Because of having negative number, the function is decreasing on the open interval 8, comma, 10. For interval 10, comma, positive infinite, evaluate f prime of 11. 11 is greater than 10, so we can use, in this case, we can use any number that is greater than 10. So f prime of 11 is equal to 11 minus 8 times 11 plus 6 times 11 minus 10, and that is equal to positive 51. Because of having positive number, the function is increasing on the open interval 10, comma, positive infinite. Now part C, at what point, if any, does f assume local maximum and minimum values? Based on what we did for part B, for interval negative infinite, negative 6, function decreasing. For negative 6, comma, 8, function increasing. So what we have here on this part from left to right, our function changes sign from negative to positive. So here decreasing and then increasing. That means at this point here we have local minimum at x equal to negative 6. And now here in this interval 8, comma, 10, our function decreasing. So here we have negative number. So prime changes sign from positive to negative. So first we have increasing, then decreasing from left to right. And at this point, which is x equal to 8, we have local maximum. Now in this part, sign changes from negative to positive. So for open interval 10, comma, 8, our function increasing because of having positive number. So in this case, from left to right, decreasing and then increasing. So at this point, we have local minimum, and that point is positive 10. So the function f has a local minimum at x equal to negative 6, a local maximum at x equal to 8, and a local minimum at x equal to 10. Answer the following questions about the function whose derivative is f prime of x equal to x squared times x minus 3 divided by x plus 4. X is not equal to negative 4. Part A, what are the critical points of f? Part B, on what open intervals is f increasing or decreasing? Part C, at what point, if any, does f assume local maximum and minimum values? To find critical points of f, set f prime of x equal to 0 and solve for x. So x squared times x minus 3, this is what we have in numerator. So this one equal to 0, solving for x. X is 0 and 3. At the point x equal to negative 4, f prime is undefined. So -4 does not belong to the domain of f. That means that -4 is not critical point. And based on what we have for domain of f, negative infinite, comma -4, union -4, comma positive infinite, our critical points are 0 and +3. Now based on domain of f and critical point, here we have non-overlapping open intervals, negative infinite, comma -4, -4, comma 0, 0, comma 3, and 3, comma positive infinite. Now evaluate f prime for interval negative infinite, comma -4. Use any number that is less than -4. So in this case, I'm using -5. So f prime of -5 is equal to -5 squared times -5 minus 3 divided by -5 plus 4. That is equal to positive number. So this means f is increasing. Now here on this part we have -4, comma 0. So evaluate f prime of -2. -2 is between these two numbers, -4 and 0. So here we have -2 squared times -2 minus 3 divided by -2 plus 4. So f prime of -2 is equal to a negative number, and that means f is decreasing. Now for open interval 0, 3, evaluate f prime of +1. This +1 is between 0, 3. So that is equal to 1 squared times 1 minus 3 divided by 1 plus 4. And this is equal to a negative number. So our function f decreasing. For open interval 3, infinite, evaluate f prime of 5. So 5 is greater than 3. Any number greater than 3, we can use that to evaluate f prime. So here in this case, I used 5. And this is equal to 5 squared times 5 minus 3 divided by 5 plus 4. And that is equal to a positive number. This means f is increasing. Now part C, at what point, if any, does f assume local maximum and minimum values? Now based on what we had in part A and B, here we have these intervals starting from left to right. For this open interval negative infinite, comma -4, our function increasing. And for open interval -4, comma 0, our function decreasing. So f prime changes sign from positive to negative at x equal to -4. But the point is f prime is undefined at x equal to -4. So -4 is not critical point. So this means there is no point at which f has a local maximum. Now here in this open interval 0, 3, again we have negative number. This means our f decreasing. Moving to the right, we have open interval 3, positive infinite. Now here on this part we had positive number, so we have positive sign and our function increasing. So what we have here on this part, f prime changes sign from negative to positive at x equal to 3. This means f has a local minimum at x equal to 3. Answer the following questions about the function whose derivative is given below. Part A, what are the critical points of f? Part B, at what open intervals is f increasing or decreasing? Part C, at what point, if any, does f assume local maximum and minimum values? F prime of x is equal to sine x minus 1 times 2 cosine x minus 1. X is between 0 and 2 pi inclusive. Part A, set f prime of x equal to 0 and solve. So we have sine x minus 1 equal to 0, solving for x. X is pi over 2. And here we have 2 cosine x minus 1. So solving for x, that is equal to 0. Here we have cosine x equal to 1 over 2. So x is pi over 3 and 5 pi over 3. So critical points are x equal to pi over 2, x equal to pi over 3 and x equal to 5 pi over 3. Based on these critical points, we have non-overlapping open intervals 0, pi over 3, pi over 3, pi over 2, pi over 2, 5 pi over 3, and 5 pi over 3, 2 pi. Now part B on what open intervals is f increasing or decreasing. For open interval 0, pi over 3, use any number that is between 0 and pi over 3. So here I'm using pi over 6. F prime of pi over 6 is equal to sine pi over 6 minus 1 times 2 cosine pi over 6 minus 1. Using calculator, I round it to 3 decimal place and the answer is negative 0.366. So function is decreasing because of having negative number. Now here on this part we have this open interval pi over 3, pi over 2. I'm using 5 pi over 12, which is between pi over 3 and pi over 2. So f prime of 5 pi over 12 is equal to sine 5 pi over 12 minus 1 multiplied by 2 cosine 5 pi over 12 minus 1. Using calculator, rounded to 3 decimal place, and that is positive 0.016. Because of having positive number, our function increasing. Now moving to right, we have this open interval, which is pi over 2, 5 pi over 3, and the number that I used here for this part to evaluate f prime is 13 pi over 12. Using calculator, our answer is 3.691, and that is positive number. Because of having positive, our function increasing on this open interval. So moving from left to right, now we have this open interval 5 pi over 3, 2 pi, and 11 pi over 6. I use this number, which is between 5 pi over 3 and 2 pi. So evaluating f prime based on this point, 11 pi over 6, using calculator, rounding to 3 decimal place, our answer is negative 1.098. So we have a negative number. Because of that, our function is decreasing. Now part C, at what point, if any, does f assume local maximum and minimum values? So what we have here, x is between 0 and 2 pi inclusive. And based on what we had in part A and B, here we have open interval 0, pi over 3, and our function was decreasing in this open interval. What this means, the function is decreasing on the right of x equal to 0. So that means the endpoint at x equal to 0 is a local maximum. And here on this part, we have this open interval pi over 3, pi over 2. The function is decreasing on the left of x equal to pi over 3 and increasing on the right of x equal to pi over 3. So what we have here is that function is increasing in this open interval. So the critical point at x equal to pi over 3 is a local minimum because f prime changes sign from negative to positive. From left to right, now we have this open interval pi over 2, 5 pi over 3. The function is increasing on this open interval. So what we have here is that the function is increasing on the left of x equal to pi over 2 and increasing on the right of x equal to pi over 2. So the critical point at x equal to pi over 2 is not a relative extremum. So here on this part, we don't have local minimum and we don't have local maximum. Moving to right, now here we have this interval 5 pi over 3, 2 pi. Our function is decreasing on this open interval. So f prime changes sign from positive to negative at x equal to 5 pi over 3. But that means f has a local maximum at x equal to 5 pi over 3. the function is decreasing on the left of x equal to 2 pi. So that means the endpoint at x equal to 2 pi is a local minimum. Therefore, the function f has local minimum at x equal to pi over 3 and x equal to 2 pi, and local maximum at x equal to 0 and x equal to 5 pi over 3.